So today we're going to be simplifying radical expressions. Over the past 2 days, we've been working on this. We have simplified radical expressions with numbers only, and then we simplified radical expressions with variables only. Today we're going to combine those two concepts. So if we look at this first example, we want to simplify the cube root of 54, x to the ninth, y to the 11, z to the 10th. So our first step is to break it into two cube roots. My first cube root is going to be the cube root of 54. And then I'm going to rewrite a second cube root with only my variables. So I'm going to write cube root of x to the ninth, y to the 11th, z to the 10th. And then we're going to do the number part first. So we're looking at cube roots. So we're looking at these numbers here. If you notice, 54 is not on that list. So 54 is not a perfect cube root. So what we need to do is we got to find a perfect cube root that divides into 54. And if there's more than one, we pick the biggest one. Well, there's only one perfect cube root that divides 54, and that's 27. So I can break the cube root of 54 down to the cube root of 27 times the cube root of what? Well, how many times does 27 divide into 54? 2 times. So, what is the cube root of 27? The cube root of 27 is 3. We don't know what the cube root of 2 is, so I need to leave the 2 under my radical. And now I'm going to do the variables. So I'm going to do my first one. I want to see how many times does 3 go into 9. 3 goes into 9 evenly with no remainder. So 9 divided by 3 is 3. So that means I'm going to have 3 x's on the outside of my radical and no x's left under it. Now let's do the y's. How many times does 3 go into 11? 3 goes into 11 3 times with 2 left over. So that means there's going to be 3 y's on the outside that I can pull out, and then there's going to be a remainder. Because 3 times 3 is 9, and 11 minus 9 is 2. So there's 2 y's left under my radical. And then last, we're going to do the z's the same way. How many times does 3 go into 10? It goes into it 3 times with a remainder of 1. And since our index is odd, we don't have to worry about the index is 3, so that's an odd number. We don't have to worry about using absolute values. So this is your final answer. 3x to the cube, y to the third, z to the third, cube root of 2, y squared z. All right, so let's try another one of these. When you're doing these on today's assignment, I want to see all of the steps. I don't want just the answer. I need to see the steps for you to receive full credit. If you want to get full credit, show the steps. Okay, so let's erase this. Let's look at this problem over here. This is a fourth root. So the index here is even. So that means we might have to use absolute value symbols around our final answer on certain parts of it. But we'll wait till the end to see. All right, so we're going to do this one the same way. Our first step is to break it into 2 parts. Break it into the fourth root of 48 and the fourth root of x to the 5th, y, z to the 17. Now, since we're looking at fourth roots, we're looking at this column. We're looking to see if 48 is a perfect fourth root. It's not. But 16, I believe, divides into 48. 48 divided by 16 is 3. So I can break the fourth root of 48 as to the fourth root of 16 times the fourth root of 3. And then if you look at your chart, the fourth root of 16 is 2. So we have 2. We don't know what the fourth root of 3 is, so the 3 stays under the radical. And now we're going to do our variables. So here, 4 goes into 5 once, with 1 left over. 4 goes into, remember on this y, there's a 1. Can 4 go into 1? No. So the y, you can't pull out any y's. The y variable just stays under the radical. And then last, does 4 go into 17? Yes, it goes into it 4 times with a remainder of 1, because 4 times 4 is 16. And 17 minus 16 is 1. So there's 1 z left under. All right, so this is the answer so far. But remember, our index was even. So now we need to see if we need to put absolute values around any of my variables on the outside of my radical. So when you have an even index, you have to use absolute values if your variable has an odd exponent. On the z, we got 4, which is even, but on the x, we got an exponent of 1. So I'm going to need to put absolute values around the x. So the final answer would be 2 times the absolute value of x, z to the 4th, the 4th root of 3xyz. That would be your simplified answer. And again, I keep saying this, but I want to see all of the steps. In order for you to receive full credit, you need to show your work. I'm not going to give you that many problems to work out. So show your work. So let's do a couple more examples here. So let's do, I don't want to do this one. So let's do this one right here. This is a square root. So square roots. So that means I'm looking for a perfect square that divides into 63. 63 is not a perfect square, but we're going to start it off like we did the other ones. Let's break it into 2 radicals. So the square root of 63 and the square root of x to the 5th, y, z to the 8th. Like I said, 63 is not a perfect square, so let's find a perfect square that divides into 63, and that's going to be 9. 9 times 7 is 63. So the square root of 9 is 3. You don't know what the square root of 7 is, so you gotta leave that as 7. And this is a square root. So this is one of the most common radicals that we use. So since it's the most common one, remember, mathematicians are lazy and they don't want to have to write the index out every time since they use square roots more than any of the other roots. So remember, there is really a 2 here. The index is a 2. So how many times does 2 go into 5? It goes into it twice with 1 left over. And then does 2 go into the variable? Does 2 go into the exponent on the y? Does 2 divide into 1? No. So you can't pull out any y's. And then last, does 2 go into 8? Yes. Goes into it 4 times with no remainder. So my answer is 3x squared z to the 4th square root of 7xy. And now, we just want to make sure we don't need to use absolute values or not. Because we might have to. Because remember, the index is an even number. The index is 2. We have an even number here and an even number here. Even number here and an even number here. So we don't need to use any absolute values. You only got to use absolute values when you got an even index and then an odd exponent on your variable on the outside of the radical. Well, we got an even index and even exponents on my variables. So my final answer is just 3x squared z to the 4th, the square root of 7xy. So now I'm going to give you some problems to do on your own. So again, I'm going to want you to work these problems out on your own sheet of paper. Take a real clear picture of your work. Make sure your picture is not blurry. I need to be able to read it and make sure you're showing your work. and then upload it to Canvas on this assignment.